Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss Laplacian operator, that is grad square, in terms of orthogonal curvilinear coordinates. Let's begin. The Laplacian operator is given by grad square, that is grad vector dot grad vector. Therefore, we can write grad square phi is equal to grad dot grad phi. Grad square is the Laplacian operator, but if we consider a vector is equal to grad of phi, the gradient of a scalar is a vector, that is grad phi is equal to a vector, then grad square phi is equal to grad dot a vector. As we previously discussed, the divergence of a vector, that is grad dot a, we find out 1 by s1 s2 s3 del by del u a1 s2 s3 plus del by del v a2 s3 h1 plus del by del w a3 h1 h2 equation number 2. This is the divergence of a vector in terms of orthogonal curvilinear coordinates. Here a vector is equal to grad phi, and the grad phi we know that is the gradient of a scalar 1 by h1 del phi by del u u1 cap plus 1 by h2 del phi by del v e2 cap plus 1 by s3 del phi by del w e3 cap, which is equal to again we know a vector is equal to a1 e1 cap plus a2 e2 cap plus a3 e3 cap. Comparing these two, we get a1 is equal to 1 by h1 del phi by del u, a2 1 by s2 del phi by del v, and a3 1 by s3 del phi by del w. Now we put the values of a1, a2 and a3 in equation 2, we get, therefore grad square phi becomes 1 by h1 h2 h3 del by del u 1 by h1 del phi by del u h2 h3 plus del by del v 1 by h2 del phi by del v h3 h1 plus del by del w 1 by h3 del phi by del w h1 h2. We just put the values of a1 a2 and a3. So for simplification, for our simplicity, we arrange 1 by h1 h2 h3, that is del by del u h2 h3 divided by h1 del phi by del u plus del by del v h3 h1 divided by h2 del phi by del v plus del by del w h1 h2 divided by h3 del phi by del w, which is the required expression for that of Laplacian operator, that is grad square, in terms of orthogonal curvilinear coordinates. So with the help of this video, we understand the concept of Laplacian operator grad square in terms of orthogonal curvilinear coordinates. Grad square is equal to grad dot grad, therefore grad square phi is equal to grad dot grad phi, but we take a vector in terms of gradient of a scalar, that is grad phi, then grad square phi is equal to grad dot a, that is the divergent of a vector in terms of orthogonal curvilinear coordinates, and we have to compare this with that of a vector in terms of components a1 e1 cap, a2 e2 cap and a3 e3 cap. We find out the values of a1 a2 and a3, and finally put these values in that of grad square phi. The equation becomes this, and for rearranging this equation, we have to finally found the result of grad square phi is equal to 1 by h1 h2 h3 as taken as constant, and del by del u of h2 h3 divided by h1 del phi by del u plus del by del v of h3 h1 divided by h2 into del phi by del v plus del by del w of h1 h2 divided by h3 into del phi by del w. This is nothing but the Laplacian operator, that is grad square, in terms of orthogonal curvilinear coordinates. So with this useful video lecture, let me wind up this session. Thank you.